A few years ago, a team of engineers at OMRON were given what sounded like an impossible task.
Create a relay with higher current capacity but lower heat generation, which is a problem because if you double the current, you don't double the heat, you quadruple it. So higher capacity and lower heat don't really go together. But instead of saying that's impossible, the team went all in. They developed around 40 new models, filed 16 patents, and performed nearly 660 simulations and experiments. What they've got was the G9KA, a completely new kind of high-capacity relay with an ultra-low contact resistance of just 0.2 milliohms. But that wasn't the end of the story. OMRON continued developing the G9K relay family, including the G9KB, G9KC and the G9KJ. All aligned with OMRON's DMS Green project, which is a significant initiative aimed at promoting decarbonization activities for customers and the company itself. So, to understand how these 4 relays actually help make the world greener, we need to look at them one by one. By redesigning the contact structure, contact pressure and the materials, OMRON achieved an initial contact resistance of just 0.2 milliohms. That's already very low, but at hundreds of amps, this tiny number decides whether the energy goes where it should go or turns into heat. Less resistance means lower losses. Lower losses mean less heat, and less heat means more efficient system, especially in battery storage, power distribution, and industrial electrification. G9KA is all about moving a lot of energy efficiently, which is exactly what a low-carbon energy system needs. Many key parts of modern energy systems operate on high-voltage DC, such as batteries, energy storage systems, and DC fast chargers. And switching high-voltage DC is especially challenging. With AC, the current naturally drops to zero, helps arc extinguish. With DC, that never happens. G9KB was designed specifically for these high-voltage DC systems. The standard version supports up to 50 amps at 600 volts DC, while the high-capacity model extends this range up to 50 amps at 800 volts DC or up to 100 amps at 600 volts DC. All while ensuring stable and predictable switching behavior across a wide operating range. What makes it especially relevant for the energy transition is its ability to support bidirectional power flow. This means that the energy doesn't just flow from the grid to the car or to the battery, it can also flow back. That is essential for renewable integration, grid stabilization, and efficient use of stored energy. Now, G9KB doesn't just switch power, it enables flexible energy systems, which are the cornerstone of carbon neutrality. The third relay, the G9KC, focuses on something very practical: scale. Most EV charging points that are installed worldwide are AC chargers, not DC fast chargers. If we want millions of charging points, they have to be compact, reliable, and affordable. The G9KC is a 4-pole, high-power PCB relay designed specifically for 3-phase AC EV charging. With switching capabilities up to 40 amps at 480 volts AC, it supports 22 kilowatt AC charging while remaining compact enough for PCB mounting. Compared to traditional contactors, this means smaller enclosure, automated assembly, fewer cables and screws, and better production efficiency. It also includes options like mirror auxiliary contacts, allowing continuous monitoring of contact status, which is a critical safety requirement in the EV chargers. The G9KC helps make EV charging not just technically possible, but economically and logistically scalable. And finally, we have the G9KJ. In high-voltage DC systems like fast EV chargers and energy storage, you can't just connect large capacitors directly to the power source. The inrush current would be enormous. That's why these systems use a pre-charge circuit that's gently charging the capacitors through a resistors before the main path is closed. The G9KJ is designed specifically for pre-charge circuits. It's a compact PCB relay that closes the circuit, making up to 25 amps at voltages up to 1500 volts DC. It is optimized for short duration operations, not for breaking high voltage DC loads. By replacing bulky DC contactors with a PCB relay, the G9KJ helps with making high voltage systems smaller, lighter and more cost effective, especially in DC fast chargers and large energy storage systems. There are two main features across all four relays that make them even more suitable for EVs, renewables, energy storage and grid interaction. The first one is efficiency. All four focus on minimizing losses through low and stable contact resistance. Less wasted energy means lower emissions over the lifetime of the equipment. And the second shared feature is the low coil power consumption. All four relays are designed to support reduced holding power using techniques like holding voltage reduction or an externally implemented PWM drive circuit properly designed to ensure stable operation. This allows the coil power to drop from several watts to well below 1 watt in steady states, which adds up dramatically over years of operation. Those relays don't generate green energy themselves, but they make green energy efficient, safe and scalable, and they are available right now at tme.eu.